Hi, this is Chuck Benedict, mentor for Team 997 Spartan Robotics in Corvallis, Oregon. This is the second video in a series on writing a WPILib device driver for a color sensor. So I thought I would, before I get called out from anybody on what exactly it is that we're doing and it not being exactly right, I thought I would talk about a device driver and what that is and what it is that we're actually going to be doing, so that you didn't get confused. So what I have up here is an article, and I'm going to link this to the video, to writing device drivers in Linux. And for those of you that don't know, the roboRio is actually a Linux, or it runs a version of Linux under the covers. You don't really hardly ever see that unless you SSH into it. But that's what it's running in effect. And to be very clear, this series is not really about writing one of these drivers, and I wanted to talk a little bit about that because I always think it's important to try to learn something as you're doing these projects. So it's useful to understand what a device driver actually is and what it is that we're going to be doing, which isn't quite that, but it's close. Device drivers, in the Linux world, really in the Linux world, you've got three levels of abstraction. Down at the most basic level, you have hardware, and in the center, you have what's called kernel space. And the reason it's called that is because the operating system, the kernel of it, is kind of this protected area. Because if you think about it, you want the operating system of your device to always be stable and always be up and available and never crash. So the area of the operating system is usually a fairly protected area of code, such that any interaction from the outside world, it goes through the operating system and talks down to the hardware, such that if anything up in the upper areas called user space has problems, it doesn't impact the operating system and the kernel space below it. So interacting with hardware in the Linux kernel is done within kernel space, and it's done within the context of a loadable module, which typically is written as a device driver. And then when you write an application, you are usually conversing with the device driver, which is then talking to the hardware for you. And for anybody, if you've never written a device driver for Linux before, it's an interesting exercise. It's actually very instructive, and it's not really that hard. And this is actually one of the best articles I've ever read that talks about how to do it. Now, to be clear, we're not doing this. What we are going to do instead, so if you go to the WPILib suite GitHub site, and I encourage you to do this because it's very instructive about the support that's been written for you to write robot programs. There's a tremendous amount of code here that is instructive on what's kind of going on behind the scenes. So I encourage you to go look at this library. It may be overwhelming at first, but if you take one little bit at a time, you'll actually get a really good appreciation for the breadth of the capability that's here for you. And it then allows you to do things like we're about to do, which is kind of write something new, but base it on something that already exists. So in WPILibJ, that's the directory, and let me blow this up. There is a class here, ADXL345I2C. This is a class that implements a device driver for an accelerometer that plugs into the I2C port on the roboRio. So let's take a look at this class, because we're going to be writing a class like this, but for the RGB color sensor. So what does that mean ultimately? Well, in the case of this accelerometer, the bottom line, and let's go to the bottom because that's where the interesting stuff is. The bottom line is we are implementing the init sendable method on this class. This class inherits from, let me go back to the top, I should have mentioned that. This class inherits from sendable base. And sendable base has a method on it called initSendable. And so if you think about what is kind of has to go on the upper layers to make this work, when a robot program instantiates, it is going to enumerate all of the device drivers that have been registered to it, and it's going to look for this method called initSendable, and it's going to call into it, and the act of calling into it is going to register a method to be run periodically that's going to fetch data from your device and then publish it to the smart dashboard. So you can see the code here is doing just that. It's going to register this key to the smart dashboard 3-axis accelerometer, and it's going to also register this function, this anonymous function that is going to get called periodically by getting the acceleration data off the accelerometer. And this method right here is actually a method that's implemented in this class. We'll go look at it here in a second. It's actually right here. And then after getting the acceleration data, it sets the entries on the smart dashboard with the acceleration data. And then the get acceleration method up here is actually what's calling onto the device to get the information. And I'm not going to go into more detail on this class, but ultimately we're going to be reading information off the I2C port based on the data sheet that this accelerometer publishes, so that we can surface that data up and put it on the smart dashboard. So in effect, that's what this device driver is doing, but it's not running in Linux kernel space, to be perfectly clear. It's running in user space. It's a subtle distinction. It's not particularly relevant, but it's important to understand, the system architecture and kind of where these things are running. This device driver that we're about to write, it's not running down here, it's running up here. Nonetheless, though, the way that you use it is that you would just simply instantiate this class in your application, and by virtue of instantiating it, then automatically those accelerometer values are available on the smart dashboard, and then your robot program can just read in and consume those values, and then you can make your hardware take action on them. So that's all for this video. Just wanted to be clear about what we're going to write, and we will in subsequent videos get on with the task of learning about how to write these for the color sensor. Thanks for watching.